Hello and welcome. Today we are going to learn about machine learning. Machine learning is a type of computer programming where computers can learn how to do something without being explicitly programmed to do so. Instead of giving the computer specific instructions on what to do, it learns from data and can make predictions or decisions based on that data. We will be going to see affinity propagation, which is an unsupervised clustering algorithm. So, what is unsupervised clustering? Unsupervised clustering is a type of machine learning technique where a computer program is used to automatically group similar objects or data points together without any prior knowledge of what these groups should be. The goal of unsupervised clustering is to identify natural groupings within the data, which can then be used for further analysis or decision making. Some common applications of unsupervised clustering include market segmentation, image and document classification, and anomaly detection. What is affinity propagation? Affinity propagation was first published in 2007 by Brendan Frey and Delbert. Affinity propagation based on the concept of message passing. Affinity propagation, AP, is a clustering algorithm that identifies clusters by iteratively exchanging messages between data points. AP creates the exemplar points that explain the other data points and are the most significant of their clusters. The algorithm does not require the number of clusters to be predetermined. The basic idea behind AP is to represent each data point as a node in a network and to define a similarity metric between nodes. The similarity metric measures the degree to which two data points are similar or dissimilar. It can be defined using various distance measures, such as Euclidean distance or cosine similarity. How are messages sent? AP iteratively updates two matrices, the responsibility matrix and the availability matrix. The responsibility matrix represents the degree to which a data point is a good candidate to be the exemplar of another data point, while the availability matrix represents the degree to which a data point is available to be the exemplar of another data point. The exemplar is the data point that represents the cluster center. Let's understand the algorithm by taking the example. Suppose that we had the following dataset. Each of the participants is represented as a data point in a 5-dimensional space. Following table shows the preference of 5 participants. Now we calculate the similarity matrix by using the equation barring those on the diagonal. Every cell in the similarity matrix is calculated by negating the sum of the squares of the differences between participants. In the next step we calculate the responsibility matrix by using the following formula. We use a separate equation for updating the elements on the diagonal of the availability matrix than we do the elements off the diagonal of the availability matrix. In the last step we calculate the criterion matrix. Each cell in the criterion matrix is simply the sum of the availability matrix and responsibility. The highest criterion value of each row is designated as the exemplar. Rows that share the same exemplar are in the same cluster. Thus, in our example, Alice, Bob, and Carrie form one cluster whereas Doug and Edna constitute the second. The following graphs illustrate the visualization of the affinity propagation algorithm. Here are some pros and cons of affinity propagation algorithms. Like the advantages are, it automatically determines no of clusters, handles complex data structures, robust to noise and fast convergence. Disadvantages are it is computationally intensive, sensitive to initial conditions, it may not scale well, and it is difficult to interpret. There are numerous applications of affinity propagation in the field of urban planning. Like identifying neighborhoods, traffic flow analysis, land use classification, and for environmental analysis. Thank you.